Welcome to School of Computing. In today's session, we will be discussing double linked list and circular linked list. In double linked list, we will have a node with two pointers. So in the linked list, in the single linked list, we had a node with data and a pointer. So this was single list where a node has two components, data and a pointer. So this was single linked list. In double linked list, we will have two pointers. So I'll have one pointer, let us call it as left and right and data. So a node has three components, data with two pointers. Both pointers are capable of pointing to another node, means they are all self-referential structures. So when we implement them through structures. So both left and right pointer are used to point to another node. So double linked list will look something like this. So you have multiple nodes. So with the help of pointers, I will be able to point bidirectionally. So from one node I will be pointing to another node, and the left pointer, maybe this is left, you call this one as right, and of course I have a data column, data. So left pointer can be pointing to another node. So right pointer will point to one node, left pointer will point to another node. So we have two pointers capable of pointing to two different nodes. So we need not use the word left pointer and right pointer. You can call it as a forward pointer and backward pointer. This double linked list has got variety of applications. Especially the double linked list is used in many places in browsers, and wherever you see navigation applications, like in your inbox you will be seeing some forward button, backward button to navigate from one set of emails. Like in any inbox you will see somewhere around 50 emails, and if you want to visit the previous emails you will press an arrow button which is found in the bottom of the screen. So you will find a bidirectional arrow which will help you to move from one set of emails to another set of emails in the inbox, like forward and backward buttons. They are all implemented internally using double linked list. So there are many real-time applications, especially within the browser, your navigation systems, undo, redo applications. So double linked list is very important, and it has got lot of use cases. So when the last node, for example, I have three nodes, node 1, 2, 3, node 1, 2 and 3. Whether it is a double linked list or a single linked list, it can be anything. For example, it's a single linked list, let us say. So this pointer is pointing to the second node, second node is pointing to the third node. Now, what do you mean by circular linked list? Circular linked list means if this third node, the last node, if the pointer of the last node is pointing to the first node, so if it forms a circle, if the last node points to the first node, then the list is called as circular list. The circular linked list is also very important. Again, it has got many useful applications. One very common application is within the operating system. In several CPU scheduling algorithms, circular list is used, especially in round robin algorithm. So like that, there are lot of use cases of both a double linked list and circular linked list. And hence, it's very important for us to understand how to implement them in C programming language. So how do we implement double linked list and circular linked list? So first of all, I need to define my node. So if I talk about double linked list, so I need a node. In that node, we need to have three components: data and two pointers. So to create this kind of node, I have to implement a user defined data type. So what we will do, we will create a user defined data type using structure, and our structure should look something like this: struct node. Data can be of any type. Let us assume it is integer data, and the pointers should be of node type. So struct node star left comma right. So whenever we implement double linked list or circular list or any other data structure, defining the node plays an important role, and hence the structure definition should be very clear for us. So in the double linked list, I will be having two pointers, and in the circular list, I can implement it as a single list or a double list. But the point is, the last node's pointer should contain address of first node. So this is the structure. Now when we want to implement double linked list, we can implement double linked list by creating this kind of structure and performing operations on it, like inserting a new node, then probably deleting and displaying. So let us try to implement and understand how double linked list is actually implemented in C programming language. So as we have discussed, we created a node type struct node into data. I have two pointers, one will be pointing to the left and another will be pointing to the right side element, or you can say forward, backward, previous, next, whatever may be the name you can give. Now you know very well the purpose of a pointer called as head. Struct node star head equal to null. Head is a special pointer which is used to point to the starting node, and it is initialized to null because in the very beginning the list does not exist, and hence head will be pointing to null. The moment a node gets created, head will be pointing to that node. And down the line, when we start creating multiple nodes, head will be pointing always to the first node. Accordingly, we have to write our code. Now we have created another two nodes. One is called as temporary node and a new node. And these two statements are written as global variables. So why I made head temp and new node as global variables? Because I'll be using them across multiple functions in my program. That's the reason they are made global variable, because in C language there is no way to share a variable within multiple functions until unless you make it global. So I have three functions. Insert function will help me in inserting the node, display forward and display backward. Why we are writing two functions? We are implementing two functions so that one can understand, like, there are bidirectional arrows in the sense pointers, which will help me to move in the list in both directions. So one is forward, another one is backward. Two functions we have written. Let me begin with implementation of main. So since we prefer to use a menu driven program so that it will be easy for tracing it out. So we created a menu with insert, display forward and display backward options, and of course an exit option. It's an infinite loop which will run continuously as long as user opts for exit. So I take the user input in a choice variable which will be passed to switch case, and in case 1, as the option 1 says, it is insertion, we call the insert function, and case 2 is display forward and case 3 is display backward function. Fourth option is exit of 0. Exit is a built-in function used to terminate the program, and by any chance if user inputs a wrong number apart from 1, 2, 3, 4, if user inputs any other number, it will come to default case where we will print a message invalid input or invalid choice. Now let us understand the implementation of these three functions. We begin with insert. So when the insert function is called, the very first statement is I am asking user to enter the data, and we are creating a node, means using malloc. Malloc, you know very well, it is used for dynamic memory allocation. So using malloc, I am requesting the operating system to allot memory for the node. And you all know very well, malloc returns, once the memory is allotted, malloc returns the address of that memory, piece of memory which was allotted, by keeping that address in a void pointer. And we have to convert that void pointer into the required data type. Since we are using that piece of memory to point to a node or to store a node, the void pointer is converted into node type. So this is explicit typecasting. We are converting a void pointer into node type. And since malloc creates a new node, that newly created node is now pointed by new node variable. And you know very well, in the structure we have seen, we have three components in the node because it's a double linked list. We have three components. New node -data, I am copying the value which was entered by the user. And new node -previous and next, both pointers are initialized with null. So for every newly created node, we store data in the data column and we keep null in both pointers. Now I need to check, is it the first time I am inserting? If first time I am doing an insertion, then obviously head will be null. We have initialized head to be null in the global variable declaration, and if head is null, it means first time insert function is being called and new node will be assigned to head so that head can point to the newly created node. Otherwise, otherwise means it otherwise the else part will come into picture during your second insert, third insert and so on. Only for the first time when insertion is done, the if condition becomes true, head will be null. In all other cases, we will come to else part. Now what logic we are writing in the else part? Suppose if I am inserting third time, where I want the third node to be inserted? Obviously at the end. So that logic we write in the else part. We take the temporary node and we put head in it. We put head variable is assigned to temp. Meaning is temp is now pointing to the first node. Now we are running a loop while temp hyphen next not equal to null. Temp is equal to temp hyphen next. So we are trying to move from first node to second node to third node, like that till we find a null. Suppose if there are already 3 nodes in the list, then temp will start from first node. This while loop will take temp from first node to second node to third node, and in third node's next there will be a null, so the while loop will terminate. And after the while loop is terminated, we are writing temp hyphen next equal to new node, means the newly created node. For example, this is the fourth time I am calling insert function. The newly created node is now copied to temp hyphen next, and temp hyphen next is now pointing to the, now it is temp is representing the third node because of this while loop. So temp will be initialized to first node, that is head. While loop will bring temp from first node to the current last node, and temp hyphen next will be assigned with the new node so that the newly created fourth node becomes the last element. And again new node hyphen previous is temp, because now fourth node should be pointing to third node. That's the reason new node hyphen previous is equal to temp. So the core logic of this program lies in insert function, which we have seen, and display forward and backward. It's very simple. Display forward means we begin from head, we initialize temp with head value, and if head is null it means list is empty, so you can't print anything. Otherwise we will run a simple loop from temp equal to head to temp not equal to null, and we will print the temp hyphen data. Similarly display backward. So here we assign temp to head, and if it is null again we say it is empty. Now while temp hyphen next not equal to null, we will move temp to temp hyphen next, means we start from first node, we will move temp to the last node. We only move temp, we only move the pointer from first node to last node using while loop. Once we reach to the last node, we start printing the data in the reverse direction. So while temp not equal to null, temp hyphen data, temp equal to temp hyphen previous. So I'll first reach to the last node, from there I am printing in the reverse direction. So this is the implementation of double linked list. So the only difference between double linked list and circular list is, in double linked list we are connecting first node to second node to third node and so on. In circular linked list, the last node will be connected to the first node. The moment I do it, it forms a circle, it forms a loop, and hence it is called as circular linked list. And the implementation of circular linked list is very much same as the double list, with a small addition. The last node will be pointing to the first node. Last node will be pointing to the first node. So similar to double linked list, we do have implementation for circular linked list, and the core logic lies in the insert function itself. So let us focus on the insert function. Remaining all is more or less same with the double linked list. We had a menu for which we wrote a while loop, infinite loop with a menu inside it. Similar kind of logic is written for circular list also. And look at the insert function. In the insert function, I'm asking user to enter the data, and similar to double linked list, we create a new node using malloc. We copy the data into it, and if it is the first time insertion, then head will be pointing to the new node. Now one important addition, new node hyphen next is equal to head. What do you mean by this? If there is only one element, then the first element itself becomes the last element, and last element should be pointing to first. So the new node hyphen next is equal to head. It means the first node is again pointing to the first node itself. It should happen if there exists only one node. Otherwise we will come to the else part. The way we moved temp from head to the last node, same logic we write here, and we move temp from first node to the last node. For example, if we are running insert function fourth time, it means already three elements are existing. So we move temp from head to the last node. Now how do I know what is the last node? In double linked list implementation, we ran this while loop from temp equal to head to temp hyphen next not equal to null. But here in circular list, the last node will not contain a null value. Rather, it contains address of the first node, means head. So I'll move from first node to second node, third node, like that till I find head again in temp hyphen next. The moment I find head again in temp hyphen next, it means I reach it to the current last node. So if I am inserting fourth time, then temp will start from first node. It will move from first node to second, second to third, and the moment it finds head, temp equal to temp hyphen next. Now temp will be pointing to the current last node. Now temp hyphen next equal to new node. New node is assigned as the next node to temp. Temp is currently pointing to third node. Now temp hyphen next is assigned with fourth node. And fourth node's next pointer is head. Means fourth node is now connected to first node. So this is the most important logic. How do we connect the last node to the first node? Similarly, we have a small function for deleting. We can ask user to enter any data item, and we search for the data right from the head to the last node. So we assign temp to head, and we are again run a loop to compare each and every node's data with the value entered by the user. If there is a match, then we delete that particular node using free function. Display is very simple. We run a loop from temp pointing to head to the last node, and we will be printing all the elements. That's it. So this is implementation of circular list, and double linked list implementation also we have seen in detail. Moving forward, so as we have discussed both double linked list and circular linked list, let me summarize quickly. Double linked list is a node with two pointers which can be used to move forward and backward in the list. And if the last node points to the first node, the list is called as circular list. Circular list can be either single or double. Applications of double and circular linked list. As we have discussed, browser history, navigation systems inside a browser, emails, software, etc. They all use linked list, especially double linked list. Circular linked list is used in operating systems, especially in scheduling algorithms. It is also used in many gaming applications, etc. So, I hope in today's session both the double linked list and circular linked list concepts are clear, and you will be able to implement double and circular linked list. Thank you.